Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Do you remember what were you discussing yesterday? I think we were discussing about the addition reaction of water means hydration, and how the addition of water to the aldehyde as well as ketone takes place, and there is a formation of Chem diol. How that Chem diol isolated or proved by using different methods, and why some of the compound can form the stable hydrate and why not the other. So that type of the thing we have learned yesterday, as well as we have seen these hydration shows acid type of the mechanism, acid catalyzed reaction as well as base catalyzed reaction. So this, and why that cyclopropanone undergoes readily or it can form readily products, why it's so. So that type of the thing we have seen yesterday. Today what we are going to discuss, let us look at to the board carefully the points written on it. The addition of ammonia derivatives or addition elimination reaction. Do you know the structure of ammonia? Everybody knows the, I hope you all are knowing the structure of ammonia or the formula of ammonia. What is that? That is a NH3, right? This is the structure of ammonia, or this is a formula for the ammonia. Do you know the nature of this ammonia? Yes. What is it? It is a basic in nature. At the beginning, I think chapter number 4, we have seen the basicity, acidity, this type of a concept, and their application we have learned, right? Now here what I am trying to explain here, this ammonia is a basic in nature. Why it is a basic in nature? Remember, nitrogen containing as a lone pair, and according to as a Lewis acid base theory, or Lewis, according to as a Lewis theory, the species capable of donating the lone pair are known as bases, or it may be negatively charged or lone pair, right? So or they are nucleophile in nature, they are act as a bases, and according to this ammonia, the nitrogen atom containing as a lone pair, and therefore it is act as a base. Now there are the 3 hydrogen atom. Now I am, what do you mean by the ammonia derivatives? Derivatives means by replacing one of the group is a different. Let us see here. I am writing here H2N and one is a Z. What I did here, I have replaced one of the hydrogen atom by another group which is G. I am considering here, in the book also given as a G, so I am considering here G is nothing but as a different group. Now this is called as a ammonia derivative. Understood? This ammonia derivative means H2NZ is called as a ammonia derivatives. So how many ammonia derivatives are possible? As far as the T.Y.B.Sc levels are concerned, there are 5 ammonia derivatives are there. Remember. Now what I am putting here, I am considering here Z point here. Let us see here. Z is equal to, if I am taken as a NH2, Z is equal to NH2. What I will get here? Here is the NH2. I am keeping this group is a constant, only G is changing H2N and then NH2. This is known as, let me write that one properly here so that you can clearly understood that. Now what I am taking here, Z is equal to NH2, right? Z is equal to NH2. So what I will get first one. So this H2N I am keeping as it is and then connecting as a NH2, and this is known as hydrazine. The name of this compound is known as a hydrazine. Hydrazine. The name of the first derivative is a NH2 is a hydrazine, and when these react with aldehyde or ketone, and whatever the resulting product is formed, that is called as a ammonia derivatives. Remember that one. So here NH2 is a hydrazine. Now second one, when I am putting as a this G is equal to OH, right? What I taken as a second one, H2N, then OH. This is a very important as far as the exam point of view is concerned. H2N OH is nothing but the name of this compound. Do you know the name of this compound? This is known as a hydroxylamine. This one is a hydrazine. This is called as a hydroxylamine. Hydroxylamine. The name of this reagent is a hydroxylamine. So now let us see here. This is a hydroxylamine. Now what I am taking here, NH2 is equal to NH then pH. Therefore what I am going to get here, you have to keep as this one. I am changing only as a Z. Z means one another group, so that here you are going to get H2N then NH and pH. What is the name of this compound? Do you know? The name of this compound is a phenylhydrazine. The name of this compound is a phenylhydrazine. The name of this compound is a phenylhydrazine. Remember. Now third one, what I am going to take, third one will be this one, CO, then let us see here, CO, NH2. This type of the group I am taking over here. This one is the fourth one, and the name of this compound now is a H2N. Then what I am connecting here, C double bond O, then NH2 and NH2. The name of this reagent is known as a semicarbazine. The name of this compound is a semicarbazine. The name of this compound is a semicarbazine. And now I am going to take another one. This one, NH, then NH, and this benzene ring gets substituted with nitro group at 2 and 4 position. There is a nitro group, and this one is the fifth one. I am going to connect this one as it is H2N, and then this NH, this part, then this aromatic compound here. You can write here at 2 position NO2 group and at 4 position NO2 group. The name of this compound is called as the short form of this is called as a DNP, right? DNP. Short form of this, it is one of the reagent. So DNP, and the full form of this name is called as a that is a 2,4 DNP. It is 2,4 DNP, 2,4 dimethyl phenylhydrazine. Phenylhydrazine. So this is the name of this compound. So in this way we have seen there are 5 reagents. One is a hydrazine. These are the reagents. When we are going to treat this compound, these reagents we are going to add across the carbonyl group. Carbonyl group, as we know that it may be as a aldehyde or the ketone, and whatever the product form, that product will form addition elimination. Why it is called as addition elimination, and the resulting product is formed, that is known as a ammonia derivative. Remember, these are the reagent. The name of these reagent, look at here. One, G I am replacing by NH2. The name of that reagent is a hydrazine. Second one is a OH, hydroxylamine, and then phenyl hydrazine, semi-carbazine, and 2,4-DNP. 2,4-DNP is a short form to remember, but full form of that is a 2,4-dinitro here. 2,4-di. Remember, 2,4-dinitro phenyl hydrazine. Make the correction here. We are previously written as a dimethyl. That is not the dimethyl. You cannot see here. Here, just remember, sometime the mistakes are while speaking or maybe while writing here. But remember, here I am making as a correction 2,4-dinitro phenyl hydrazine. So this is the name of this reagent. These are the five. These are the five reagents. Now one by one we are going to look why it is called as a addition elimination reaction. Now pay the attention toward this word addition elimination reaction, because we are learning addition of ammonia derivative. So before that, addition elimination reaction means what? What is addition elimination reaction? Explain with suitable example that may appear the question in your exam. So remember, how will you solve this, or what does it mean? So for that, let us see here how addition elimination reaction takes place. Now I am taking here the general reaction. What is that? RC double bond O. This one, it may be as a aldehyde or ketone, right? Aldehyde or ketone. I am considering here the general reaction. I am trying to explain the addition elimination reaction. Addition, you know that the reagent added, and elimination means the atom or group of the atom removed from that substrate is known as elimination. So, and here the addition elimination, these two words together, what does it mean, that we are going to learn here. Aldehyde and the ketone, as we know that aldehyde and the ketone containing the common group is a carbonyl, and that's why it is always referred as a carbonyl compound. And let us see here, this is a general reaction, and first one, this that is treated with H2NG, and as we know that G are the different five we have considered here. One, if you connect as a G is equal to, if you take as a NH2, that you will get as a hydrazine. If you take as a G is equal to OH, that is a hydroxylamine. If you take as a G is equal to NHPH, that is a phenyl hydrazine. Similarly, you will get as a semi-carbazone as well as 2,4-DNP. These are the five reagent, ammonia reagent you can, and they act as a nucleophilic in nature. And when this reaction takes place toward the carbonyl group, and these reactions are very sensitive toward the pH. And do you know the pH? There is a one scale is there, right? pH scale starting from 0 to 14. And from that we come to know that the what we can call it, we can know the nature of that solvent, whether solvent or what we can call it as a medium, whether it is acidic in nature, neutral in nature, or the basic in nature. And remember, pH 7 is equal to 7, that solution is known as a neutral solution. And as we know that water is a universal solvent, it is a tasteless, colorless. So everything is why it is called as a universal in nature. So this is it has a pH is a 7, means neutral in nature. And with that, suppose a 0 to up to say less than 7, whatever pH are there, that solution is always called as a acidic solution, and those are showing pH than more than 7 up to 14, they are called as a basic in nature. And one instrument used to measure the pH of the solution or anything, that the name of that instrument is a pH meter, and it is a very important as far as the chemical reactions are concerned, or in a general day-to-day life. We are coming across to these pH meters, and as we know that the blood, right, what would be the pH of the blood? Do you know that? You can find out and remember that what is the pH of that blood. So here the what we are talking about, that pH, right? These reactions are very sensitive toward the pH, means this type of the reaction, they are the rate of reaction is maximum when the pH is optimum pH. Optimum pH means what? Not the acidic or not the base, that type of the thing is not there. The optimum pH is a pH where the rate of reaction is a maximum. That type of the pH is called as a optimum pH. If you increase the pH, the rate of reaction will decrease. If you decrease the pH, rate of reaction also goes on decreasing. So that type of the critical situation is known as optimum pH. Optimum pH means what? These kind of the reaction is the rate of reaction maximum at optimum pH, not greater or not lower. At optimum pH we are getting. So these reactions are highly sensitive toward the pH that is there. Now let us look at here again, focus your attention toward the addition reaction. Now what I am going to here, that lone pair, as we know that this is a carbonyl carbon, it is a nucleophilic in nature. First what is going to happen? The addition reaction going to take place over there, right? Now this first step is addition reaction. Step number first is a addition reaction, right? But because this is going to add across this, and therefore I am writing purposely here. Here I am writing, here is a O minus, but I am putting directly OH over here, and this one is a 1H from here, and here what we can call it as this is a Z, right? And now 1H from here and OH from here, second step. Step number second, what is happening here? The step number second, one of the hydrogen from here and OH from here is removing, and therefore it is known as a elimination reaction. Elimination reaction. Addition of this reagent across this carbon-carbon double bond and this type of the intermediate form, and there is a elimination of water molecule, and the product is formed like this double bond NZ. So this type of the this is a ammonia derivatives, right? Ammonia derivatives is formed. This is ammonia derivative. This is a general reaction I am written over here. And why it is called as addition elimination reaction? Because in the first step, addition of nucleophile across the carbonyl compound, and we are getting as this type of the compound, and further it eliminate the water, and there is a formation of the compound that is called as a ammonia derivative. Let us see here, and there is a new bond is formed. Hetero bond is formed. Carbon nitrogen double bond is always formed with the ammonia derivative, and that's why it is called as these are very sensitive toward the pH. Just now I have told, or the synthetic point of view, these reactions are very, and why it is called as the general preparation. Now let me tell you about the difference between derivatives and the general preparation. And look at here, these whatever 5 ammonia reagent, whenever we are adding, the reaction taking place very easily carried out that reaction at a room temperature. For example, 2,4-DNP. These are the classical tests used to identify whether the given compound containing carbonyl group or not. So this is one of the classical tests we are performing while doing our regular practical course in the laboratory. So that is there. But here the ammonia derivatives, right? And that the bond is formed is a carbon nitrogen double bond. So that is a hetero bond is formed over there, and that's why they are the very. And what we are talking about, the difference between the ammonia derivatives and the preparation, general preparation. What are the major differences between derivatives and the preparation? Number one, remember, whatever derivatives are formed, that derivatives are always in solid form. As we know that matter has 3 states, which are those: solid, liquid and the gases, right? But here remember, whatever derivatives are formed, they are always obtained, they are always derived, or they are always getting in a solid form. Understood? This is the first. But in case of the preparation you may get in solid form, liquid form, or in a gaseous form, anything. Three states are there, so in that, so that are called as a preparation. This is one of the major difference between derivatives and the preparation. Number 2, the derivatives gives the sharp melting point, and whereas here we know that preparation you may get solid, you may get liquid or the gases, and therefore there is a range, what we can call it as there is not fixed range. But derivative, the melting point are getting as a very sharp, because all are the solid in nature, therefore melting points are very sharp, right? And as we know that melting point means there is a change in the state, physical states are changes, means what? Solid is converted into as a liquid, and therefore we can define the melting point. What is it? The temperature at which a solid is converted into liquid, that temperature is known as a melting point of that substance, and they are the with this. So this is a second major difference between what we can call it as derivatives and the ammonia. So these during the practical we will see later on, but here just have you clear in your mind the addition, elimination, reaction? Now is let us see the ammonia derivative. First one we are going to take, suppose as a general one, RC double bond OH, or let us see as a first one is a one aldehyde group is there here. Let us see here C double bond OH. As we know that, do you know the name of this compound? Yes, most of you are knowing the name of this compound, organic chemist. This is a benzaldehyde. Name of this compound is a benzaldehyde, right? And now that we are going to add hydrazine hydride or phenyl hydrazine. Let us see here one NH2 and then here OH. That is a the name of this reagent is it has a specific name of this reagent is a hydroxylamine. The name of this reagent is a hydroxylamine. And what is going to happen here? This is going to add across this, and you are going to get here the compound like this. Here here is a OH, you can remember, and then here you can write here H, and this NH, and there is a OH, right? Now this one is a addition reaction, now is a elimination. One hydrogen atom forming as a double bond where there is a elimination of water molecule, and the product form is this one. Let us look at here. There is a C, there double bond N and OH. This is a H over there, and look at here. Carbon nitrogen double bond is always formed there, and this is a derivative form. The name of this derivative is known as oxime derivatives. Oxime, the name of this compound is a oxime derivative. Remember here, this is a oxime derivatives. Oxime derivatives. Understood this one? This we got the oxime derivative. Remember this one, first one. And now second one, suppose you have this one, HC double bond OH. I am taking as a formaldehyde as a structure. And now I am adding here H2N, NH2, that is a hydrazine in presence of the ethanol. Catalytic amount, it does not require as a acidic medium because they are highly nucleophilic in nature. And what do you get here? Here you are going to get H, then OH, then NH, then NH2, this CH, and this CH forming double bond over there. Elimination of the water molecule, and you are going to get here H double bond N NH2. This is known as a hydrazone derivative. This is known as a hydrazone. Look at here, ONE, hydrazone derivatives. Remember, hydrazone derivatives, this one. Understood this one? Now let us look at as another example. What do you get? What type of the derivatives you are going to get? Let us see here. I am taking another one, CS3, C double bond O, CS3. Acetone I am taking, and now it is treated with H2N, then NH, pH. This is a phenyl hydrazine. pH, there are the three different ways to write as a pH. This pH we can write C6H5, or we can write this way also, right? These are the different way to represent that pH is known as a phenyl group. So phenyl group we can write in this way. You can write pH, or you can write C6H5, or you can write that benzene ring, monosubstituted benzene ring, and the name of this compound is a phenyl hydrazine. And what you are going to get, this addition reaction takes place over there, and you are going to get CS3, then OH, here is a NH, here is a H, I am writing here, and this one is a pH, and here again as a CS3. In the second step, there is a elimination of water molecule takes place, and what you are going to get here, formation of the double bond. Water, one H from that, from that nitrogen, and OH from that, and you are going to get the compound CS3 double bond NH and pH. This is called as a phenyl hydrazone derivative. This is known as a phenyl hydrazone derivatives. Phenyl hydrazone derivatives. Understood this one? Now this is the reaction number 3 we have seen. Now let us look at as another example over here, so that you can, once you know the first general mechanism, you can able to predict the product, because if you know the mechanism, very easy to predict the product. If you don't know if you are not knowing the mechanism, then you never predict the product. So remember, please remember that one. Now let us see as a fourth one. Suppose we have another one, that is this one. Can you tell me the name of this compound? C double bond O, CS3. Direct predict the product. Suppose let us see here. One is a CH, not CH. What is that? Let us see here. H2N, then NH, C double bond O, and the NH2. Now the name of this compound we know that it is a semicarbazine. Now most of the students get confused here. Why? Because there are two terminal amino groups are there. The two terminal amino group, one of them is going to form the double bond with that carbonyl, and there will be the elimination of water molecule, one oxygen from here, remember, and this let us see here what you have to remember in short while predicting as a product. One oxygen from here and H2 from here, that remove, and you just put here nitrogen, carbon nitrogen double bond, whatever other part you keep as it, that will be your product. That is one of the simplest trick to remember, that is while predicting as a product, remember. Now here what is going to happen, now most of the students get confused here, which NH2 group is going to react with this carbonyl compound. What do you think? What is your opinion? Whether this NH2 which is far away from this carbonyl group, or the NH2 group which is nearer to the carbonyl group, it is very near to carbonyl group, but this NH2 is far away from the carbonyl group. What do you think? Which one is going to react? So remember here, this NH2 is going to react, remember, and this is not going to react with this carbonyl group, and you may this is not going to react with the carbonyl. Why? The reason behind it, listen the reason carefully. The lone pair which is present on this nitrogen atom engage in a delocalization. Look at here, because the lone pair is not readily available for the donation, they are engaged or they are utilized for the delocalization, because as we know that oxygen atom is more electronegative than the nitrogen atom, and therefore negative charge develop on that oxygen atom. This lone pair pulling by that carbonyl group, it is not given for, it is not ready for donation. But here look at here, in middle there is a nitrogen atoms are there, so these lone pair are readily available for donation, and therefore it is going to react with this carbonyl group. And what do you get here? I am writing shortly here, pH, then COH, then here NH, then NH, then C double bond O, NH2, and this CH3 group is as it is, right? And now second, as we know that there is a elimination. First step is a addition reaction, second step is a elimination reaction, and therefore this kind of the reaction is referred as addition elimination reaction. So here forming as a double bond, OH is get eliminated, and we are getting here pH, then double bond NH, C double bond O, and NH2, and this methyl group as it is. So this is called as a semi-carbazone derivative. This is known as a semi-carbazone. Remember ONE here. And this one is called as a phenyl hydrazone derivative. This is known as a phenyl hydrazone derivative. This is known as a phenyl hydrazone derivative. This is known as a semi-carbazone derivative. Remember this one, derivative. And now let me take the another example, that is the fifth one, maybe as a, let us see here, this one, C double bond. The name of this compound, as we know that acetone, common name I am talking. I am not talking about the RUHC name. RUHC, you know that. What is the RUHC name of this compound? 2-propanone. This is a acetophenone. Acetophenone. The name of this compound is acetophenone, and I am going to connect another phenyl group over here, and the name of this compound is a benzophenone. Name of this compound is a benzophenone. And this one is reacting with this one, H2N, NH, then here this one, that is here NO2, and here I am writing as a NO2. Look at here, the main functional group is this one. So number starting from here 1, 2, 3, 4, 5 and 6. At 2 and 4 position there is a nitro group is present, and therefore it is called as a 2,4-DNP. Shortly 2,4-DNP means 2,4-dinitrophenylhydrazine, and what you are going to get over here, that is a 2,4-DNP. Again, first addition, or I am directly writing here is a product, because this H2 and this is going to form as a bond. Let me write here pH, then C double bond N, NH, and this group over here directly, here is a NO2 and NO2 over there. So this is a pH, right? And this is called as a 2,4-DNP derivatives. Derivatives means 2,4-dinitrophenylhydrazone derivative. So in this way we have seen addition of ammonia derivatives. So there are some of the conditions to form this ammonia derivatives. Condition number 1, remember, addition involves nucleophilic attack by the basic nitrogen on carbonyl carbon of the aldehyde or the ketone due to the polar character of carbonyl compound. This is the first condition for this ammonia derivatives. And number 2, that is olefin carbon-carbon double bond undergo electrophilic addition reaction and not the nucleophilic addition reaction. That is the second condition, because carbonyl group is a differ from the carbon-carbon double bond, and therefore if the carbon-carbon double bonds are present, they undergoes the electrophilic addition reaction, whereas this carbonyl group can show nucleophilic. Most of the reaction undergoes as a nucleophilic substitution reaction. Number 3, protection of carbonyl oxygen makes the carbonyl carbon more electrophilic toward the nucleophilic attack. So that is there. And number 4th one, thus the addition will be favored by high acidity, but the ammonia derivatives H2NG can undergoes protonation to form the H2NS. And remember here, this is the 4th one, is a very important one. Why it does not carry, why this reaction not carry out in highly acidic in nature? What could be the reason? Listen the reason here. What is happening here? If you use here generally what we can call it as a NH2 hydrazine hydrase, while carrying the reaction with aldehyde and the ketone, does not require as a acidic medium because they are already nucleophilic in nature. Similarly, hydroxylamine HONH2, this is hydroxylamine also as a highly nucleophilic in nature. It also does not require acidic medium, but pH, NH, NH2 and what we can call it as a H2N, then CO, NH2, NH2 and H2N, or what we can call it this one NH, NH2 at 2 position nitro group and at 4 position O2 nitro group 2,4-DNP. These 3 are required at the acidic condition, but very mild acidic condition then and then. And why? Because mild acidic condition, what is happening in case of the aldehyde, the acidic condition, this get protonated and therefore what you are going to get, C double bond O H positive charge, and due to the protonation of this carbonyl oxygen atom, this carbon atom becomes as a more electrophilic in nature. Look at here, here OH positive charge are there, and therefore normal carbonyl the electrophilic nature of this protonated carbonyl carbon is greater as compared to the normal carbonyl carbon. So that's the reason, and therefore this type of the reaction does not require acidic condition, but these three reagents required as acidic condition to carry out the reaction. But that acidic condition, the acid must be as a mild acidic condition, mild, or what we can call it as a very little catalytic amount of the acid is required. If you use as a strongly acidic condition, what will happen? As we know that the general, what is happening here, H2 here G, then NH2, right? This NH2, if you use as a strongly acidic condition like here plus, what is going to happen? This lone pair is going to attack over there instead of this Z, and what you are going to get NH3 positive charge, and the activity of that is stopped here. It does not react with the carbonyl group, and due to this reason, strongly acidic condition, this type of the reagent does not react, because in a strongly acidic condition they itself get protonated and becomes as a deactive in nature. They do not react with the carbonyl group, and there will be no formation of the product. That's the reason they are highly sensitive toward the pH. I already told you that this one. I think with this we have completed the addition of ammonia derivative. What does it mean? Addition, elimination reaction, their condition, everything we have seen. The exact condition is used for carrying out this reaction. I think with this, let us wrap up the today's lecture. Remaining one, Cannizaro's reaction, as well as some other named reaction we will see in the next lecture. Thank you. Have a nice day.